Hi, I'm Martin Bell. Welcome to the channel. In this video, I'm going to cover Seaborn. This is a data visualization library in Python. The format of the video is of live coding, so I'll be teaching you Seaborn as if I were teaching a friend that's seated next to me. And I think this makes the tutorial a lot easier to follow. If you don't know what Seaborn is, it's a very popular data visualization library in Python. It's very useful in data science. If you already know the library but didn't take the time to learn it in depth, this tutorial is perfect for you because I go through a lot of examples in the gallery, in the documentation, and just copy the code to a notebook, and I try different ways with different data sets. So it helps a lot to understand how the library works. So yeah, let's get started. Let's go to the Seaborn website, and here we can see high level description of the library, so statistical data visualization, and that's really what we need for exploratory data analysis or for doing statistical analysis. Here we have some more information, so we have some instructions to install library, the gallery with examples, some tutorials, and the API. So this means the reference of each of the functions. I think the gallery and the tutorials, they are very high quality. And if you want to learn the library, I think these are the best resources. And then there's these other kind of tutorials. So there's a kind of new API that's being developed that's object-based. And I think it's very interesting. We can take a look at it also. And yeah, here are some other plots depending on what you need. Okay, let's first take a look at the gallery. So let me open this. Here we have plots, and we can click on them and just see how it's done. So let's say you, for some reason, you need to do this type of plot, like a bar plot. Yeah, you just go here, you have some data here to run the example, and then you just need to adapt it to your own data set. So I think this is great. Another variation of this plot would be this one, called pair grid, but yeah, dot plot is better name. And this is, I think, a little bit better. And yeah, the same. You have an example that you can run line by line, understand what's going on, and yeah, just then adapt it to your data. So let's get started with one of these. This one looks like an interesting one. So grouped box plots. Okay, so this is used to compare, yeah, smoker status, how much money they leave as a bill. So it seems smokers tend to leave more money some days, Sundays, Saturdays, but yeah, not on Friday. So let's take a look at this code. So yeah, I'll just copy everything into the ShowPython notebook. So here I have some imports and some data already loaded, but let's do it from zero. So this is grouped box plot. Okay, so here we are importing Seaborn. We have this set theme thing, and this is the data that we're loading. So let's take a look at the data. Tips. Okay, so this seems to have this gender column, sex, and some numeric variable, total bill. And the box plot takes a variable on the x-axis, that's the day. We define the y-axis variable, and the hue is the smoker. So this is what defines which variable will be kind of grouping by. So let me show you what happens if I take it out. So let's just plot the distribution of this variable for each day, right? However, if I add this hue smoker, then we can compare this. And this is very useful. So for example, you might not have in the x-axis days, you might have some categorical variable, for example, and you just want to compare between two values. And this is a very common use case of box plots. So yeah, this is a nice plot. I didn't know about this trick using hue, so this is great. Okay, so let's continue. So let's go back to the gallery. Okay, so what can we choose? This looks kind of interesting. Let's take a look at it. scatter plot heat map. So I'll just copy this heat scatter. And this seems to be categorical variable. And this looks like a scatter plot with some correlation. I think it's a nice plot. Maybe with other data, it kind of could look better, but I think it's interesting to know how to do it. And there are some nice color schemes being used here. So perhaps the only thing I would have changed in this plot is remove these ones, because yeah, that's not useful. You can just set it to NA, but yeah, you just need to try. So let's take a look at this. Let's just copy everything and we can copy it line by line. So here we're setting the style, so it's wide grid. And this is data we have in this data. Oh, so this is hierarchical data. So, okay, so brain networks data set. Okay. So there is some pandas reshaping here being done. Used network. So it's kind of filtering here, and df columns, get levels, level values network, type int is in use networks. So let's see, use columns. Let's see what we get here. So this is just a Boolean array, and it's passing it to filter the data frame. Okay, let's see what we get after this. Okay, so it's kind of concatenating these two columns, just putting it in one column name, which is a lot more reasonable. Okay, and then we get the plot code. So this is the correlation, right? Which, I mean, you could just so it's in long format. So what's going on is you do the correlation. So up to this point, it's just a matrix. But if you do stack, it's yeah, you reshape it. So it's in long format. So in order to do this plot, you need to reshape the correlation matrix into long format. And then this is the plot. Let's remove this. Let's see the default, how it looks. Okay, not bad really for default. I mean, it's almost there. And I guess they added this to clean it up a little bit, but it looks very good overall. So, okay, rel plot. So we pass a correlation matrix, x level 0, y-axis level 1, hue correlation, size correlation. Okay, that's interesting. So, okay, and then the palette, VLAG, I don't know why that was chosen, but let's try with blues. Okay. I don't know, I find this one kind of nice, but so yeah, this is defining the range of the color scale. So let's see what happens. We take it out. Yeah, nothing that terrible, but because it probably uses the values that are in the data, so it doesn't change a lot. And what happens if I take out all of these things, just leave the simple? Okay, so yeah, this doesn't look great. So perhaps this is just what we need to let's see. So let me comment this out, and I'll just leave the height and the sizes. So okay, this looks quite presentable, and yeah, this is just the size of the plot. But yeah, it's kind of over plotting, so that's the problem. So size norm. Perhaps this is needed. Not necessarily. Edge color. Interesting. So yeah, it seems you need to make it a little bit larger. That's the way to solve it. Okay, I mean, I don't know. I don't think this is amazing, but it doesn't seem to require a lot of code to do this. I mean, it looks a lot better than, yeah, just, I don't know, a typical heat map. So I think this is a nice thing to know. Okay, let's move on. I'll just remove this. Okay, this looks kind of cool, the Violin plot. So this is kind of a mixture of a histogram and a kernel density plot. So it's doing the same thing as the box plot we just did. So so we can copy this because we already have the other. We have this data loaded. So let's take a look. Okay, Violin plot. So we pass the data tips. In the x-axis we put the day, so our categorical variable, so x equals day. In the y-axis the numeric variable, that's the amount paid in the bill. So this is a tips data set. So, and we're controlling by smoker, so we can think of a kind of a conditioning by smoker, right? So there is a statistical link to this idea. So okay, so let's take a look at the plot. So I would expect this is the median, and these are the third quantile or the first quantile. So it's similar to a box plot, right? So in the box plot, I think it's easier to see. So the line in the middle is the median. So the lower end of the box is the first quartile, and the higher end of the box is the 75th percentile, so the third quartile. I mean, basically, the idea of this is to capture the 50% of the distribution that's in the center. So basically, the median gives you a summary in one number of the center of the distribution, and the box gives you a range. So if something is between the first and the third quartile, that's the 50%. That's 50% of the data, and that's kind of like the idea of the central tendency of the distribution. So okay, this looks like really similar to the box plots, but the reality is, I mean, it takes more effort, I think, to understand this plot than the box plots. I mean, it's, you can see the same thing, but the reality is that the kernel density, I find it a little bit distracting, whereas the box plot is very concrete. It's very objective. It's simpler, but very objective. And I mean, if you would present this to someone with a business background, they will not pay attention to what you're showing them. And I found that box plots is something so that you can explain to people that don't have a statistical training. I think it's something people can learn. Okay, so this is the Violin plot. I think it's nice aesthetically, but probably not the best for this data. So one more thing we can try is what happens if we take this Q parameter. Nothing happens. So maybe this is, we need to take out a few more arguments. Okay, we need to remove a few arguments here. And let's try this. Okay, so this is how you add the median and the first and third quartile. So I mean, I actually prefer this to the kind of raw Violin plot, because yeah, if you look at these compared to these, I mean, I don't know, it looks kind of awful. Yeah, it has the good thing of the box plot, and it's kind of like a histogram in a way. Okay, so let's continue. So okay, let's take a look at this one. Let's see how they are thinking about this plot. So here we have a line chart, and we have some sort of confidence interval, error bands. Okay, so let's take a look at the data here. So now we're using the dark grid theme. So actually we have this data loaded already, but I'll just load it to keep things easy to follow. And we have a subject, time point, event, region, and the signal. So let's see what they're doing here. So the x-axis is the time point. So let's see. Okay, yeah, the time point. So some sort of time series idea. We have the y-axis, the signal, hue, region, and style event. So okay, let's try it. Let's see what this looks like. And I mean, yeah, I found that I think that simply too much stuff going on in this plot. It's just not easy to understand. I would have preferred kind of using small multiples, but I think the idea here, let's say, if you plot two lines, that's better. So but I mean, in order to make this plot happen, you probably have multiple observations at a given time point. So let's take a look. So fMRI query and time point equals 10. So right, so we have one observation for each subject and for each event, I guess. So so here we're using region for the color. That's the region of the brain, it seems. But yeah, event is another variable we might be interested in. So I think if you would do small multiples with this, I think that would be better. But it's an interesting plot. It's not, you don't get this type of data very often, but it's a good approach. Okay, so let's continue. Okay, so joint grid. This could be interesting. Faced grid. Let's take a look at this one. That seems like a fun plot to make. Overlapping densities. This is quite cool. So let's copy all the code, and I'll just put it here, and we can copy it as we need it. So I already have these libraries available. I just loaded them before, so that's fine. So this is the style. It includes this option, who knows why, but we can take a look at it later. So here it creates some random data and just puts it in a data frame. Okay, so what do we have in this data frame? So we have a numeric variable and categorical variable called she. Okay, initialize the faced grid object. So cube helix palette. So this is the colors palette, and this is the faced grid call. So let me copy this. So here we have the data frame. The rows of the facet grid are she. The color are she also. So, okay, this is interesting. I never did this. So, okay, so this is what we're trying to do, right? So A, B, C, D. So this is the categorical variable, and this is the x-axis. Yeah, I think this one is quite cool. I mean, I never thought of this idea, but it's kind of like small multiples in a way. So now it's mapping this KD plot. So if you haven't used Facet Grid, you can kind of think of it as, yeah, you define how a grid of plots will look like, and you can define the rows and the columns of that plot. In this case, we're doing just rows. I'm sure there are other examples where you define other options. So here we define the facet grid. So this is kind of like the boilerplate of what will go of the kind of high level plot, right? And let me just remove this and just come back here. And when we define this we have this object, and we can map function to it. And in this case, we're mapping this KD plot. That's what you use to make a density plot. And we're passing the x-axis as the variable to make the plot. And these are some other parameters. So, and that kind of looks fine in terms of the plot. So the labels are what needs to be fixed, and this also needs to be fixed. So let's see how that's done. So, and now we have all the code. So this is just another call to KD plot, and passing color none to refine. So she recline. I don't know what's going on here, but let's just run this, see what the extra call does. So yeah, this might be the color. And let's add the next line, refine. So let's see what it does. I don't know, I can't see much difference. And so this is the function to label the plot in the axis coordinates. So, okay, so then they define this label, and this will change this probably. And I think this is a very clean way to do it. It's using Matplotlib, of course, and they are mapping it here. Okay, this is a nice trick to know. Oh, they added this ABC here. Okay, and then the rest is some Matplotlib magic that basically removes the grids. So yeah, I think this looks nice. It's yeah, I don't know. I mean, yeah, probably I'm thinking of ways where you would use this plot. But basically, yeah, if you have a categorical variable and you have a numeric variable, you can kind of compare the distribution, the numeric distribution of one variable conditioned by this categorical variable. So I mean, it would work in a place, for example, where you had a box plot, where you would use a box plot. So probably a box plot is an easier way to compare this, because in this case it's very easy because the values are growing. But if they were kind of in the same range, it would be hard to get something out of this plot. So I mean, this is a nice one, but I don't see it being super useful. So, okay, so let's do this one, pair grid. I think this one is a lot more useful. So this is kind of an alternative to a bar chart. And I mean, I think bar charts are kind of overused. And I think, yeah, this is better in terms of it uses less ink and blah blah blah. So it has multiple advantages to a bar chart. It's easier for people to look at one point. They don't need to have a complete bar plotted to compare things. So this seems to involve some work to set up. So we have states here in the US, and this is sorted with some variable, crashes probably. And we have multiple numeric variables, total crashes, speeding crashes, alcohol crashes. And I think this is interesting in terms of how it's presented. You have one variable here and you can compare to the others. So let's see how this works. Okay. So I'll just copy this a little bit lower. So it starts setting the theme, white grid. Then we load this crashes data. So let's take a look at the data. Okay, so basically a state here and some, the total crashes and the crashes for other causes. Then there's the insurance premium and the insurance losses. Okay, so here we have the pair grid plot, and this is sorting the data frame by total. So this is important because it's what we are seeing in the plot, and the X variables are they are removing these columns. And so let's just check that. Crashes, columns, right. Okay, so it's keeping columns up to here, and Y bars is the state, basically. And height of the plot 10, aspect .25. And I mean, if we wanted to understand all the parameters, we can just open the help here, and there is some information of the, so height is the inches of each facet, aspect times height gives the width. So basically setting the height of the plot and the aspect, you can define the total size. You don't need to define height and width. So that's cool. Okay, and there are a lot of more options. You can pass everything you want here, really. Okay. So this is kind of defining all the variables we'll be using, and this is the plot that's getting mapped. So this is kind of like a facet grid, but different. But the same idea that you define an object here, a graph, and you map a function. So in this case, we map strip plot, and so this should already make a plot. I mean, it might not be perfect, but I mean, yeah, it's fine. So it's not terrible. I mean, in practical terms, you just need to add the line here, but yeah, let's see how they solve it. So let's just remove this and let's see the rest. So now we set the x-axis limits. So it adds a label here for the x-axis, uses semantically meaningful titles for the columns. So right, so this is what's added on the top. So let me show you here. So this is what's added here on top of the plot. And so now it loops through the axis and the title, and it uses g.axis.flat. So this is just probably creating a a list of axes. So this is using a matplotlib internally, right? So you have access to each of these subplots. So this is interesting. And basically it defines some titles, and it uses this x-axis.flat, and it sets a title. That's it. And make the grid horizontal instead of vertical. So x-axis grid false, y-axis grid true. So okay, so it's just making these lines basically. So let's remove this part just to show you what's happening. So yeah, I mean, everything's there. The labels are changed here also, but it doesn't have the X and Y grid. So hopefully now it does. So this is kind of interesting because when I saw this plot the first time, I thought the line was was up to the point, the dot, but it's just a kind of grid line. So it's not a line plot. It's just a dot plot. But still, it kind of works. It's very easy to read the plot. So this works well. And in this case, I think I like this example a lot because it's showing states in the US. There are like 50 something states. And basically, a lot of people will just make a map with this data. And the reality is that the map won't tell you this information. It won't be as useful. It will be very hard to interpret. And this plot, it's kind of easy to interpret. You can see that these states are the worst ones in terms of driving security, and you can go down and look at the best ones. So yeah, I think this is a nice plot. Oops. Okay, so let's take a look at another example. So I think I covered this one in a video already. So I don't want to repeat it. This looks like an interesting one. Take a look. Scatter plot with varying points, sizes, and cues. So okay, they went a little crazy with all the options here, but I think it's good to demonstrate how you can customize scatter plot. So let's take a look. So this is the MPG data. So basically data of cars, and there's one observation for each car. And let's take a look at the data. So we have in the x-axis the horsepower, y-axis MPG, hue origin, so origin the country, and size weight. So let's see. So MPG, origin, value counts. Okay, so most of the cars are from the US, but some are from Japan and Europe. And then we have sizes, 40-400, alpha, 0.5. So this controls the opacity of the plots. I'll change all the options and it will make sense in a second. Palette muted and height 6. So let's first do the plot. And okay, I mean, this looks quite nice. So we have the color, defines the country of origin. So all of these are the US cars, but we can see Japan and Europe cars are more on this end of the plot. So they have a lower horsepower. So I think already the plot, I mean, it's informative. So the only part that I wouldn't necessarily agree with using is the size, because size is generally not a way people, yeah, it's not the best way to, yeah, to show a relationship. I generally try to avoid using it. So yeah, this kind of shows the same thing, but it's easier to see. And we can see that there are some cars from the US in this area also. So not necessarily shows the same thing that what we're looking at before. Okay, so what I want to know is where are these sizes? So let's take a look at the documentation here. So sizes, size or sizes? Sizes. Okay. An object that determines how sizes are chosen when size is used. List or dict arguments should provide a size for each unique value data, which forces a categorical interpretation. The argument may also be min-max tuple. Okay, so it's so it's controlling how the sizes are, how the argument is used. So let's take a look. So the okay, so yeah, it's making the points larger or smaller. That's what's happening. But I mean, I don't know. I find this it's not very useful, not very easy to understand. I think this is a really good argument to know about, the alpha. I mean, that controls the opacity of the point. So in this case, you see that we have some points that are on top of each other, and that's the way to control it. So if I remove this and put alpha equals 1, this is how the plot looks. So you can play with this around a little bit and see what works and what doesn't. So I mean, this is a nice scatter plot. I mean, we don't have a lot of observations here, so that makes it easier to plot. But we have a nice kind of nonlinear relationship here. Okay, so let's continue. Okay, so what else looks like something interesting? Another box plot, lmPlot. Okay, this one I think is a really nice plot to know how to make. So I mean, it's a scatter plot, right? But you add a linear model to the scatter plot, and this is very useful because you can get very quickly an idea of the relationship between two variables. You can see if they are linearly related or not. So this is the SCOMP dataset. So it's a very famous dataset to show that, you know, linear regression has some issues. So basically all these plots have the same linear model. So it's a kind of a nice way to show that there could be a lot of issues with the linear regression model. So look at this one. You have one point here, all these points here, and the line is the same. So yeah, just something to keep in mind. So this has data set X and Y, and the lmPlot basically just pass a data frame, the X variable, Y variable, and the color you will use, the hue you would use, and these are some extra options. So let's see what happens without them. Okay, I mean, already you get something relatively coherent. So call wrap equals 2. So what this does is basically to say, okay, just put 2 plots in the first row and start adding plots in the next row of the plot grid, right? So that's why we get this result. So for example, if I put 3 here, it will put 3 and then start adding on the next row. So think of the grid of plots as a matrix. So this is the matrix, in this case, 3 by 3. And this is one row, another row, and these are columns. So col wrap equals 2. It's just putting 2 plots in each row. A little bit confusing, the naming, I know, but it will start to make sense. But if you don't know about it, just try a few values and you'll figure it out. So then we have these values, let muted, confidence interval none. So you can just remove this and leave the confidence interval. I mean, I think it's fine to have it in some cases, but might be too much information. And then there is a way to pass more arguments. So these are scatter keywords. So basically what you're doing here is passing some arguments to each scatter plot. So I could put alpha 0.5 here. And yeah, that's it. And I think this is size. So to make the plot, the points very small. So let's see, 5. Yeah, so it was 50 originally, so I'll leave it there. And I mean, I find this plot very useful in general, because yeah, it's you can think of it as a linear model where you are conditioning by multiple variables. But maybe this is not the best data set to show it. Maybe we can try with the diamonds data set. So let me see. So diamonds, okay, so we can plot the carat and the price using the same code, literally. So I'll just change the data frame here. In the x-axis, I will have the carat, so that this is the weight of the diamond. And in the y-axis, I'll have the price. And okay, we need one more categorical variable. So it could be the cut, and I'll just replace it here, and I'll just put 3 here. Yeah, maybe this one we can do 5, size 5. Let's see what happens. Okay, I mean, for first attempt, it looks quite decent. So this line kind of continues going up, even if there isn't any data. So, I mean, that's not ideal. So we would like to limit the y-axis, but yeah, I think this explains more the idea a little bit better. So the idea in this case is that we have the price variable, that's the target variable in our kind of statistical model that we have in our head. And the carat, that's the x-axis variable, that's the predictor. So what we want to understand in this plot is, okay, how does the carat explain the price? And the advantage of using these linear models is that we can see that there's some sort of almost linear relationship. It's kind of a little bit quadratic here. It's kind of turning, but I mean, linearly, it's not very far from a linear relationship. And we can see that, I mean, some of the cuts, they are pretty much the same thing, but if you go to the fair cut, it's different. So this kind of opens up a lot more to the right. And I think this is kind of like an intuitive thing of this data set, because you would expect that the cut ideal and premium, they have the largest prices. But I think the logic is that the weight, if the weight is very large, maybe the cut is, yeah, it's not perfect. So, I mean, yeah, you get this kind of very, with a plot, yeah, a model with a lot of variability here. And in these cases, it's a little bit tighter. So it's not that spread. So look at in the same, for the same price. So the y-axis is price. You have diamonds that go from 2 to 5 carat. So, and in this case, it's, you know, yeah, almost 2 to 3.5. So, yeah, you have a few outliers here, I guess. Okay, and this is, I think, yeah, a lot more interesting than this plot. Hope it helps to understand the idea. And okay, so let's take a look at another example. So showing plot. So this is some sort of scatter plot. I think this plot is actually very nice, and it's very useful when you have overplotting. So so I'll just copy it here. So basically, yeah, this is the idea, but I'll use the diamonds data set here. So just copy the code here. Set theme sticks. Okay, let's just try that and do this. So okay, diamonds. So we have the data equals diamonds, x equals carat, and y equals price. Kind hex. So this is the same, kind of the same plot we made before. Yeah, it doesn't look as nice as the example. And yeah, that's just what happens with the defaults. So there's probably something else we need to change. Let's continue. Then we have these. Okay, so these two look interesting. ClusterMap, this plot. Okay, this is kind of a clustering algorithm, and there is a kind of heat map on top of it using the same data we used before. I mean, this is kind of interesting. Let's see how it works. I think there's a plot in R that kind of does this automatically. So it's interesting they were able to replicate it. So here I'll just print the data. Network pal. So this is the color palette. Network loot. The map str use network. So what is going on here? So okay, so this is some sort of mapping of each of these values, 1, 5, 6, the network here, and here they change the names and create a series with it. So let's do this. Let's print this just to make sure we're following the idea. Okay, so this kind of has a color mapped to each of the elements of the network. And let's just plot this. So they are just passing here the correlation. So I think this is just a matrix. Oh, okay, it has the multi-index here. And yeah, I think this is quite interesting. So it's kind of doing this clustering, hierarchical clustering internally. So we don't even have to do it. And I think the heat map looks nice. So it's relatively similar to the other one. I think I like more the squares. But yeah, nice plot overall. Useful to show correlation. Okay, let's continue. Okay, let's take a look at this Trivariate histogram with 2 categorical variables. So what is going on here? What is this? Okay, this looks like some sort of, we can think of it as a scatter plot heat map. So so we have a variable here, price and color, and yeah, it's just plotting the kind of frequency, and it's having using a small multiple the clarity. So a categorical variable. Okay, this is kind of interesting. So I think the new thing to me that I haven't seen before is that you have categorical variable here, and generally when you do a scatter plot you use two numeric variables, but here you have numeric and categorical. Let's see how this works. So we'll load the diamonds data that we already have, and here's the call to the plot. So yeah, simply the x variable, numeric variable, color, and let's use yeah, cat here instead of clarity. It has a few less amount of values. Okay, I mean, we can kind of see something here that yeah, for these two categorical variables, color and cut, it seems that the price has some sort of relationship, but it's not very easy to read this plot. I mean, that's, I think, the problem. So let's try through also here. Okay, and call wrap 3. Yeah, I mean, yeah, cut equal fair looks kind of lighter than ideal, which might make some sense. But yeah, I mean, I don't know. I think it's a nice plot. Maybe, yeah. I mean, if you would have, for example, a numeric variable here that you discretize and convert it to categorical, maybe it's easier to read because you have some sort of order. But yeah, I think it's fine. It's interesting. So we did this already. What else? So this is kind of the same as the HexBin one. So instead of yeah, HexBin, you have a scatter plot. So, but let's try it. Let's do it anyways. So we have these tips already. So let's set the theme. And okay. So data equals tips. So I don't know. I think it's just easier to pass the data first. So Swarmplot, data equals tips, x total bill, y tip, kind reg. So what we did in the HexBin plot is kind x, but that's the only difference here. So, and this is just a scatter plot. And I think this is a nice plot. I'm not a big fan of these kind of distributions added on the top because I don't think they add a lot. But I mean, it looks nice, you know, it's appealing. But yeah, in general, I don't find a lot of value of this extra plot. But it's a nice thing to know how to do. So if you go here, you can see all the options that you have. So kind, scatter, KDE, histogram. So let's try hist. And this should do some sort of 2D histogram. Okay, and it crashed. So what happened? So okay, comments in the code that say to do. That's not great. Quad mesh object has no argument truncate. So just need to remove this probably. Okay, there we go. Oh, okay, this looks quite decent, I think. I mean, I think this is yeah, very useful when you have overplotting, when you have a lot of data, and yeah, nice plot overall. Probably the other one is cleaner because you have the model that's giving you some idea of what the linear relationship, and from that you can yeah, you can see if the data actually has this relationship or not. Kind of has it, but yeah, it's not very strong. Okay, let's see what else we can find. Yeah, the line plot, the rel plot, this one, I think you can watch this in my other videos. I'll link to it in the, so we already have done this, and this looks kind of cool. I mean, this is nice, but I really have a hard time reading these plots. I mean, it's a kind of 2D histogram, 2D KD plot or something. I don't know, not very human comprehensible. So okay, what else do we have? Cat plot, let's see. Regression fit over strip plot. So yeah, I mean, this doesn't seem super useful to me. I think the strip plot is fine, but yeah, why would you do this? Why would you do that regression model? Swarmplot. So this is some sort of scatter plot with categorical variables. I mean, and this looks nice, but maybe it just looks nice because there's very little data here. Let's give it a try. Let's give it a try. Maybe we can try it with some other data. So let's use diamonds. The cut will go here, and we'll just put the price. And let's see. Yeah, the idea is that we pass a categorical variable in the y-axis and a numeric variable in the x-axis. So, but still, it takes a while. So here I am passing x, that it's a numeric variable in the x-axis, cat in the y-axis as a numeric variable, and q to color it. Which, okay, they're using a different variable to color it. But yeah, I mean, I don't know why it takes so long. Just not ideal. Just the one last experiment. Okay, maybe we just need to take a sample. Okay. So it's definitely not the same experience as the documentation example. But I mean, it gives you some warning to solve the problem probably, so that's not bad. But yeah, I can expect that this will be a terrible plot. Okay, let's continue. So so I think, yeah, this could be interesting. Let's take a look. What is this? Faceted ECDF plots. Okay. Oh, you can do the cumulative density function. So this is kind of interesting. Yeah, this is a mess. But I mean, yeah, it is what it is. I mean, it's when you try to plot more data than 20 observations, things break. So let's try this one. Let's see what this does. So actually, I think this one will work for a larger data set. So I'll use the diamonds again. So let me just remove this. So just pass diamonds here, and we pass the let me just clean this up. So yeah, okay, let's see. So we have displacement. So we have just a numeric variable here, and this is the proportion. So let's see price, and we pass cat as a column. Oh, no. So this is a factor, so a categorical variable called origin and the color model year. So, okay, this is kind of interesting because you have this kind of origin here where the car comes from, and you can plot the cumulative density function for all the models. So so in this case, the diamonds. So let's try a few ideas. So we can try the color in the hue and the for the facet call, the cut. So, and we don't have this palette, so it doesn't matter really. Okay, and this looks kind of more interesting, I think. So call wrap. Let's say 2, 3. And yeah, I mean, so what we're showing here is the cumulative density function, the estimation of this function for each of the colors for each of the cuts. So I think that's kind of interesting, but still it's not very easy to read, and yeah, it just but yeah, you can interpret this that, you know, the proportion of the data that has up to this price. So that's how you would interpret it. But yeah, it's a very statistical type of plot, so most people in a business setting, they won't be able to follow it. But yeah, it's a nice plot. Maybe in some cases it's useful. So okay, let me remove a few of these. So cat plot. Let's see this. Okay, so plotting a 3-way ANOVA. So it's not very common that we would be doing a 3-way ANOVA, but it can happen. And let's take a look at it. So this is statistical type of analysis. It's analysis of variance, so ANOVA. So yeah, it's very, very commonly done if you're doing statistical analysis for research. And I think it's kind of easy to read. You have these actions, and you are conditioning by diet, and no fat and low fat. And these are kind of the activities people have been doing. So resting is this one, walking, so this, and running. And so the person that has no fat has a higher pulse. So, and these values, they are a little bit higher. So there are some differences. But yeah, I think this is a nice plot. I mean, it shows a lot of information in one plot. It's probably enough to do one of these, but you can see a lot of things here. You can see these how things change if you do 1 minute versus 30 minutes of exercise, and how things change depending on the diet. So let's see how the data looks like. So we have this ID, the type of diet, the pulse, and the time. So how much exercise, how much time you were doing exercise. So we put in the x-axis the time. So in the y-axis the numeric variable, and the kind. So that would be okay. Kind is the activity, and yeah, and we have a few other variables here. So I mean, the fact that you don't have to do all the calculation of taking the average, the standard error here, and it just does it for you. I mean, it's amazing. So let's see if we can adapt it to some other data set. Let's give it a try. So basically we have the diamonds data frame. We could put as the x axis variable. We can put the color, for example. That will be different colors. Should have some different relationship between the weight and the price. So the y variable could be the price. Hue could be the cut, the diamond cut, and the color, yeah, maybe the column, right? Is yeah, let's try without this first. Let's see what happens. Let's see if it makes sense. Okay, a little bit messy, but I mean, it's kind of could be interesting. So, I mean, I could use a different variable on the x-axis. So maybe just change the variable. So just so try color here and cut. Yeah, but I mean, with the standard error, it kind of gets a little bit messy. So error bar. So what changed there? So error bar none, let's see. Okay, there we go. So this is kind of plotting the means, and yeah, it's okay, height 8, aspect 25. Okay, let's see. Okay, yeah, just want it to be a little bit better. Okay, there we go. So, I mean, yeah, this looks like something useful. So each color is a line, and we have the cut here. So the dots are the mean, the average of each cut and color. So, I mean, you're basically comparing two categorical variables, how they relate to price. And we can see that the color have some sort of ordering, that shade, yeah, this is I, H here, and it's nice that it has a color scheme there. And yeah, it seems premium has generally given the color the highest price. But this is what I find interesting in this data. The good diamonds, they have generally a lower price than the fair yeah, diamond. So for each color. So maybe not this one, but this one, the black one, you see that good is lower than fair. The same with this one. And it generally happens that the fair one is not the worst type of diamond. And that can be explained because the weight might be larger. And look at the ideal one. So the ideal one also is generally has a lower price than the fair one. So, I mean, this is kind of useful in terms of yeah, a way to quickly relate multiple categorical variables to one numeric variable. So I can also remove the color, but yeah, this kind of breaks it. Yeah, and you could add small multiples here. So let's say you want to include clarity, and this will make the the plot a little bit more messy, but let's try it. Okay, so I'm just adding another categorical variable, and yeah, let's put 15. Okay, this doesn't look very good. Map size. Okay, there we go. This looks better. So now we can make one of these plots for each clarity value. And I mean, what I would like to see here, this is just a quick plot you can make, and just want to see if the relationship changes a lot, and or not, it remains similar. So I would look at the color scheme here, and this is what I would expect as remaining similar. But here we see something kind of weird. So it might also depend on the clarity, this relationship. So this looks different, a different pattern than this, for example. So yeah, I mean, but yeah, it makes the code, it makes the plot a lot more messy. And this, I think it's kind of interesting to look at. Okay, so we got something interesting there. And yeah, I want to wrap it up. Maybe we can do this one last one. Okay, scatter plot with marginal ticks. So this is kind of like the similar idea we did before, that we have some sort of histogram or density function here on the sides, and we have some sort of scatter plot here. So yeah, I think this is relatively easy. So let's just do it, and we can close with this idea. So here we're reading the MPG data. So x-axis MPG, y-axis acceleration, and then it calls plot joint. So scatter plot. So probably, yeah, this is kind of like the complete plot that has everything. So what happens if I just print this? Probably, yeah, that's nothing. So so this probably does the scatter plot, okay, and this the marginals here. So you can probably change this to histogram. Let's see. Okay, yeah, or KD plot, KDE plot. Okay, let's see if we can add one more. Okay, no, we can. But I mean, yeah, I think this is yeah, I mean, it's a nice plot, but generally I don't find a lot of value in this. So one thing I wanted to cover is the tutorials and the user guide. I think they are really high quality. So let me close this. So first of all, you have this API overview that basically explains the logic of the library. So basically, yeah, here you have the types of plots according to what you can do with them. So if you just want to do some analysis of two numeric variables, for example, you can use lmPlot. If you just want to analyze distributions, you have these options like a histogram, a density plot, the cumulative density function plot, the RAG plot. And then there are a lot of options for categorical variables. So strip plot, box. I mean, the main one I think is box plot for categorical and numeric variables. But you have bar plot here. And yeah, I think it helps a lot to know that depending on what you want to plot, you can go to these functions. And as you can see, all the functions are called some kind of plot and then the plot word. So scatter, plot, line, plot. So all you need to learn really is the kind of unique types of plots that you can make, and And yeah, it's just very consistent, very logical, I think. And okay, let's take a look at this overview. So here they're reading some data. They have these penguins data. They just plot a histogram. They pass a numeric variable on the x-axis and a color, hue equals species, and they stack the bars. So, I mean, the reality is that this is not very easy to read. I mean, I would not recommend you do this. So this is another way to do the same plot. It's a little bit better, but what I don't think is needed is the kind of painting the area of these densities. So this is the KDE plot is an approximation of the distribution. So, but yeah, this is still not great in my opinion. So, and they continue doing the same thing, and I think this is the best way to look at this data, where you have a histogram on each subplot. So these are called also small multiples in data visualization. And yeah, you have this plot, you pass the data frame, you define a numeric variable on the x-axis, and for a histogram, that's really all you need. The only difference in this plot is that you're passing this hue option that controls the color of the histogram, and then call that defines if this plot is a 1/3 matrix. So we have one element here, another one, and another one. So it just defines the variable that creates this grid of plots. So, and here we can see that this distribution here is very different to this one. So it's a lot better than just putting everything together. Okay, let's continue. So access level functions make self-contained plots. So yeah, I mean, here you can do some kind of mix of matplotlib. So you create subplots, and then you can do scatterplot and his plot. So you can combine two types of plots in one plot. Figure level functions own their figure. Yeah, I mean, yeah, I don't think this is very interesting. So this is customizing plots from a figure level function. So the figure level returns a facet grid instance, blah, 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 blah. But yeah, this is kind of allowing you to change the axis from this global figure level function. So you can just change it directly. But yeah, I think there aren't a lot of, I mean, I think it's useful to walk through this, but I would just try to use the library to do whatever plot that I need. So this is a nice plot, but the reality is that you really rarely can use it. It just kind of works for like a example type of data. So not super useful. So there's a few more things that are interesting here. So this is an introduction. I think they made a great job in this tutorial because they put the type of plots that are really useful. So let's take a look. So Seaborn is blah, 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 built on top of matplotlib. So we know that already. So this is kind of a scatter plot where you can customize the shape, the size, you can add colors. And I think this is a great example of why this library is really excellent. You can, in these 3-4 lines of code, you can do all these. And yeah, here they are doing the scatter plot with X and Y variables. Just pass this call function, so time here, the facet grid column, and then they pass a color, style, and a size. So in my opinion, I think it's just too much stuff going on in this plot. Generally, I would try to avoid doing so much stuff. generally the color is one thing I would use if there aren't many categories, but I wouldn't go a lot more into that. So the size is something that I think you should try to avoid using. So here you have a few options, how you can change the theme, high-level API for statistical graphics. So yeah, another example of lmPlot. But yeah, I mean, this is an example of like too much stuff going on. I mean, there's just too much. I think you can try to break this down in other plots if you want to explain it. Statistical estimation. So we went through this one already, I think, at the start. But actually, this one is better than the example they have in the gallery because they're using small multiples. So basically, they have this kind of line chart grouped by two variables. So lmPlot, okay, this is a good example of linear models. So basically, the idea here is that you're making a scatter plot between total bill and tip, but yeah, you have a linear regression model for each smoker value, and you can compare the relationship of these two conditions using the line of the regression plot. And I think that's very, very valuable. So it's a lot better than just looking at the plot. Distribution representation. So this is mainly histogram, density functions, the cumulative density. Okay, plots for categorical data. Yeah, I mean, I don't think this is very useful. I think just better to use a box plot. Same here. These Violin plots, you know, they look nice, but they're not super useful. So, I mean, this is a plot I see a lot being done, and I really don't like it because you don't really need this bar to plot this data. It's just like too much ink in a way, and you can just do this differently. Could be a line between these 2 points, for example, and a dot and a line instead of the bar. I think this looks awful. It's probably the one I hate the most from everything that's available in the library. So multivariate views on complex data sets. So yeah, I mean, this is kind of, you know, this type of example type of charts. I mean, yeah, it looks nice in this example, but if you try it with more data, it might not look great. Same here. So, okay, lower level tools for building figures. So, yeah, this is kind of interesting. You have this pair grid that is what does this kind of grid plots, and you can control what you put in each area. I think this is nice. It's a little bit more complex, but looks nice. Opinionated defaults and flexible customization. And I think this is one of the reasons this library is so great, because if you try it, the defaults generally look well, or they don't need a lot of effort to look well. Yeah, this is a nice plot. I think it's very nice. You have a scatter plot and you pass a color, and it uses a reasonable color palette. Okay, this is I don't like this at all. I mean, yeah, I think this is kind of like a kind of plot to avoid. Okay, so this is the kind of introduction, right? It has some nice charts, but I mean, not a lot. So this is the data structures. So this is something that's very important. How do you have to set the data in order to for the library to use it? So there are two ways to do it, just using what's called long form or also tidy data, or wide form data would be kind of a matrix. In general, in the examples that we saw, they use long form data. So this is what it means. So each variable is a column, each observation is a row, and yeah, that's it. So generally, I think it's kind of like a mistake to have wide data. I would consider that's not ready for data analysis. But yeah, it depends. So some libraries just also work with kind of wide data. So this is an example of wide data. For simple data sets, it's more intuitive to think of the way of a spreadsheet. Yeah, I think this is just terrible advice. So I think, yeah, you just should never try to analyze data in this format. It can work, but yeah, it's not great. And in this case, it works, but it works with wide data directly. But I mean, it's very difficult to customize the plot. So if you can do one plot and then you can't customize it, yeah, it's not good. So these are some examples of messy data, blah blah blah. Yeah, I think this is good if you're learning data manipulation and data visualization together. It's a good guide to follow. And then they have this objects interface, which I think this is quite interesting. I didn't get much time to look into it, but they started developing another API that I think it's kind of yeah, very interesting. So let's see how this works. So they imported like this, Seaborn objects as SO. So I'll just copy this here. And here we go. Okay, so this is the first plot they're doing. So it's just a scatter plot. So SO dot, okay, and they add this function. So the idea, I think, is they kind of keep adding things to the plot object, setting properties. Okay, dot class is example, blah blah blah. So let's see how this works. So X and Y, so this doesn't change. So we kind of define this globally in the plot. So maybe we can indent this also. SO dot color she point size 4. So yeah, it's just changing a few properties of the dots. Mapping properties. Okay, so you can map some properties in the plot call. So SO plot. Yeah, so this is the same as before. This is the new part, right? Color, species, point size, body mass. So the size of the dots is controlled by this variable. I mean, I think this is nice because you can define like everything you have in your mind about the plot, and then you just decide how you visualize it. Okay, let's see another one. So this is changing the edge color here and edge width. So okay, so it's changing the color of the edge, so not the point. Okay, it looks nice. I think looks interesting. So let's see how it looks with another data set or other plots. So health exp. So I don't know if I have that data set. Okay, looks like it's there. Okay, so health expectancy, life expectancy. Okay. Okay, this is interesting. So you pass this data frame. So we pass the x-axis variable, y-axis variable, and the color, and we add a line. Nice, very intuitive. Okay, go down. So so grouping by country. So the difference is it's not colored by country. Okay, so you can group by a variable but not change the colors or add a legend. That's fine also. I mean, maybe sometimes you just want something simple. Transforming data before plotting. Statistical transformation. Okay. So this is kind of aggregating data in the plot. So penguins, X species, body mass. So X is the species and body mass G. So this is just counting, I think. Or I don't know what's going on. Or just taking some sort of average. Okay. So, okay, this looks like a better idea. So instead of a bar chart, just use a dot. And yeah, I think this is nice because you can just define the variables, define how you want to visualize things, and then, okay, aggregate it. So when forming groups by mapping properties, this is applied to a group separately. So, okay, this is nice also. So we have species, body mass by color. So it's kind of grouping by color and then just spotting that. So if you would do it in pandas, it would be something like group by sex, and you would keep the body mass. So I think this is the calculation that's going on, but let's check. So me. So add delete. So female is here around 300 and 4,000 for male. Yeah, so this is what's going on. Okay, so this is kind of the data we would use to make this plot. But it's really nice that it's doing it for you. You don't even have to do a group by in pandas. Okay, so resolving overplotting. So yeah, okay. So this is a bar chart. Just dodging the bar charts. Okay. so.bar. So basically you just do the same plot as here and you use a bar chart. And it seems you can do so.dodge. So just put them side by side, which is of course better. And you can probably change this to dot. This is nice. So it works for any type of data visualization. Okay, let's see what else we have here. So yeah, this is the dot example, but with more points. Okay, maybe let's see if it works with boxplot. Okay, it's not there. Yeah, just wanted to give it a try. So this is the shitter. I think also very interesting. So you kind of can compare some sort of distribution. So yeah, and I think this idea of adding things to a plot, it's very intuitive, and yeah, it's very helps you try things very quickly. Creating variables through transformation. So this is a bar chart. and histogram. So, so let's see, species. Yeah, because species is a categorical variable, right? So we don't have histograms for categorical variables. So this is the bar chart. So the kind of counts. So what's the difference? Oh, right. Yeah, it needs to aggregate the data. So, and if we use a numeric variable, this is what happens. Okay. So we get a histogram. Fine. So plot. Okay, this looks interesting. So what is going on here? So we have penguins data frame, have X, Y, and color. So this is a numeric variable, the categorical variable, and this is another categorical variable. So I think the way to think of it is, let's say you start like this, and you add a dot, then you aggregate it. So let's say you take the mean and you put it side by side. So one color for each sex, and then you can add this range. Let's see what it does. Okay, so it kind of adds this line. So let's see what's this error bar thing. And this is adding dodge. Okay, so it just puts it on top of the dot. Yeah, I think this is a really nice plot. And yeah, I think it's kind of very intuitive how you build it. You kind of build it step by step. Okay. Orient, marks, and transforms. So so here we're doing just a bar chart, just changing the axis. So okay, so this is just changing the orientation. Orient Y. So let's see what happens. So this is what we're getting here. So what happens if I remove orient Y? Oh, okay, it doesn't work. So yeah, so I mean, it's kind of the same thing, right? So you can just do it differently. So adding multiple layers. So I think, yeah, this is what I wanted to get to. I mean, you can just add dots and then decide to add a model on top of it. And I think this is really a great way to do this. Okay, so this seems kind of simple. So so let's see what else. So do we have a lowS function? No. Polyfit. Okay, polyfit. So what is polyfit? Let's see if we have some options here. Fit a polynomial of the given order and resample the data. So we can put 2 here, let's say. Okay, yeah, this is nice. A nice option to have. Okay, and now they are using it with 2 variables here. So we pass a color and it does a model for each. So I can just pass 1 here and it will do a linear model. Okay, layer specific mappings. So you can, yeah, you probably can change things of each line. So of course, if you do it this approach, it will be harder to customize the plot. I think. So to recap, there are 3 ways to specify the value for property: mapping a variable in all layers, so that happens in the plot call; mapping a variable in a specific layer, so here, and setting the property directly. Okay, so this is the faceting and pairing subplot. So I think this will be a lot easier with this approach, because you can start with a simple plot. So let's say you start like this, and then you say, okay, I want to facet it by species. And yeah, it's a lot more intuitive. So then let's see how this looks like. So here we have a numeric variable in the x-axis, facet call equals species, row sex, and then we do a histogram. So yeah, I mean, I don't know, it's something you can do with Facet Grid already. It's just a probably simpler way to do it, because you have this plot here and you're faceting before. Okay. Okay, this is with line charts. So we have this health expectancy data set. We pass the year on the x-axis, life expectancy on the y-axis, and we face it by country, and we add a line. So yeah, I think this is also very intuitive, kind of similar to what you can do with other functions. Yeah, now they are making it a little bit nicer. I think just comparing all the data. So okay, let's see. So they have the plot here, facet wrap, so nothing changed here, and this is the line chart, like the thicker line chart. Here they are plotting all the lines in each subplot. So yeah, I mean, quite nice for the 4 lines of code you needed to do this, right? And I mean, I think you can get the idea that you have this thing, that this kind of API that gets created by adding things on top of it. So so here we have a pair plot. So let's see. So the length, depth. So we have 2 numeric variables in the x-axis and 1 on the y-axis. Okay, so so this is you can combine faceting and pairing, so long as the operations answer plots on opposite dimensions. So this is getting a little bit more advanced, but let's see how it works. And okay, so you have this x variable, these 2 different x variables, length and depth, and you can condition by male here on female here, and the colors are mapped by the species. But yeah, I don't know when you would do this kind of plot. It's not, I don't think it's very common. And let's see, it seems here you can integrate it with Matplotlib, and they show how you can do it. Just create figures, some sub figures, and then yeah, make a plot for each. So, but yeah, I think this is really nice. They have a lot of examples, and it kind of looks like the ggplot library in R. So it seems that they made a different version with similar ideas, and it looks really, really high quality. And you can see here that yeah, this plot is very complex, and with 3 lines of code, you know, it looks pretty good. So I think at some point people will start using this API also. think we'll start seeing it a lot more. But yeah, I think this is nice also. So so look at this scatter plot, how much code I need to set up the color scale like this. Let's give it a try. So okay, so here you define the data frame, you pass the X and Y variables, add the dots. So this would be the default scatter plot, probably. Okay, and this defines the ticks on the x-axis. This defines the labels on the y-axis, and this defines the color. So oh, okay. Color equals continuous tick. I mean, I don't know. I mean, already the default plot looks so good that I don't know if you even need to do this, but and this is using shapes or yeah, another variable, which kind of too much stuff. But yeah, I think this is, you know, for how simple it is, looks great. So you have X, Y variables, the color variable, and color flare. So the blues. Okay, you can change the color palette there, and yeah, actually this looks better. So what happens if we don't do anything? Okay, just set some value. Yeah, I think this covers, yeah, I think I covered everything in Seaborn, the documentation. We didn't do all the gallery plots, but I think you get the idea, and really this is the way I learn new libraries and new topics. I just go through the documentation, try to follow their tutorials, and the reality is that you don't need to know everything about the library. You just need to be able to grab an example, try to adapt it to your data, and that's it. You don't need to know every little detail about it. But the exercise of going through the examples and trying them, changing the plots a little bit, I think it's really the best way to learn, because you can yeah, practice with some data. And the documentation of Seaborn, I think it's excellent. So in the API section, you have all the detail. So let's say you want to read about the lmPlot, you can go here. I mean, this is similar to what you would get in Schuppeiter, but they also have examples here that are very high quality. So yeah, I think there's everything here for you to learn data visualization. And if you are good on using this library, I think you can do everything that's needed for most of the data science work. So yeah, I hope you enjoyed this video. Thank you very much.